Hello and welcome to my How I Done It video for my CM5 inspired custom computer case. This may be quite a long video, so I'll split the video into these 4 parts. Part 1. Why? I saw Jurassic Park many years ago when I was a child, and I got obsessed with the connection machine CM5 in the background. How can you not love the fancy lights? I wanted something like this for myself one day. A couple of years ago I came across this website. There was a page where the website author showed how he had resurrected a CM5 front panel. The comment section on this page became a meeting point where the focus was trying to recreate the effect on an Arduino Uno and some Max7219.matrix modules. Unfortunately, it looks like the website author changed some website things and the comment section was lost. Fortunately, the older site was captured by the Wayback Machine, and also copies exist on Pastebin. So, I got the code into an Arduino Uno and a matrix module and it worked. And now I need to create some sort of fancy computer case and stick this on the front of it. This is where this project started. Part 2. CM5 Lights. So, I had a good place to start. I had the code from Pastebin, I found the required libraries online, installed them into the Arduino IDE libraries directory, and all went well. You need to make sure you have the exact version called for in the code, otherwise it will not work. This fooled me for ages. The matrix module is based wholly around a Max7219 LED driver, driven from an Arduino Uno over an SPI interface. Here you can see the Arduino running the Max7219 LED matrix module. Here are a few of the steps I went through to get the whole thing running. There are several different options for chip packages on the Max module, but for simplicity I chose the DIP. I did prototype a SOIC version, or a SOIC, however that's pronounced, which worked equally well. I started by drawing the schematics of the matrix module in Easy EDA. I deleted the matrix module itself and implemented discrete LEDs. I chose this as I wanted to choose the spacing of the LEDs. I chose 3mm LEDs in 8x8 blocks. The whole setup is 9 modules tall, so to speak. All the Max chips are cascaded. The software only creates enough random pattern for 4 segments, and then this data is just repeated for the other segments. Unless you're looking quite hard at it, you won't notice the repeating pattern. Once I was happy with the schematics, I created a crude evaluation PCB and got it made of JLC PCB, nice and cheap. This board worked quite well and showed that my schematics were correct. I then revisited both the layout and schematics and improved upon them. I then copy and pasted the layout so each PCB contained 2 modules, reducing cost of JLC PCB. I added mounting holes, confirmed against my CAD that everything looked like it would probably fit, and I got these boards manufactured, and luckily these boards also worked too. I was quite pleased. Having 9 blocks led me to have to solder over 570 LEDs for the CM5 panel, discrete LEDs, but it was worth it. Now I needed to adapt the Arduino Uno to fit into the small area allotted for it in the case. I made a small adapter PCB to fit around a corner, and this is the shape of the board that has the Arduino Uno in it. Really, it's not an Arduino Uno anymore, and a custom board that just has the microprocessor, a 5V power supply on it, but it fits in the area quite well. I dry fitted the PCBs together throughout the process to make sure I had not made any mistakes in CAD. Luckily, no critical fails, but a few small minor ones. I soldered it up and it all looks quite well. Looking at the PCBs all in all, it is very odd shaped, I'll admit, but that's just because of the area I had allowed myself. I had initially planned to use an LM7805 as the 5V power supply, but it got unacceptably hot, even with the heatsink. I moved to a Traco Power 7805 drop-in replacement, switch mode, and that works quite well. Part 3. Voltmeters. So the voltmeter itself is actually 2 parts, which are combined together. There is a 7-segment voltmeter, which I got from eBay. The 7-segment display is this one. It's pretty simple. And the supply voltage is also the measured voltage, so the meter drops out at about 3 volts, but that's not an issue when you're measuring a 5 or 12 volt rail. And there is the circular LED bar graph, which is a board I designed. Arduino based, with 17 LEDs driven off it. One ADC is used to sense the voltage input and translate it into the bar graph. More voltage means more LEDs turn on. There is a simple potential divider circuit connecting the supply voltage to the ADC input on the 80 mega. There is also a variable resistor on the sense input for finer adjustments. All other usable I/O on the 80 mega are dedicated for LEDs. Power on the voltmeter is provided by an LM7805 from the 12 volt supply. The board went through several revisions, so I decided exactly what it was I wanted, dimensions, electrically. I started constructing with a crude Arduino shield to test my code, and then afterwards I started schematics and layout in Easy EDA. I went from 13 LEDs to 17 LEDs, and I also placed an Arduino ISP by the end of the development process. I'm quite happy with the end result, but if I was to respin the board I would do things a bit differently. I would perhaps use a switch mode power supply or something less wasteful than a linear regulator, and also use surface mount components where convenient. I have a loose plan in the future to implement a MAX 7219 LED driver like in the CM5 Lights themselves to drive more LEDs, but I'm not quite there yet. Part 4. Final assembly. The casing itself is made out of black 5mm acrylic. The front panel is made out of 5mm clear acrylic with a black tint. This was chosen so when all the LEDs are off, it all looks black. I designed the panel in 2D CAD. I went to a local hackerspace with a laser cutter to cut the acrylic. I test cut with some cardboard with equal thickness and then hot glued it all together. Once I was happy that my CAD and laser cutting methodology was correct, I then placed the acrylic in the laser cutter and started the process. When this was all done, I headed home and started gluing the acrylic together using a solvent called Tencel 12. It was stinky, but I got the job done. It sets after about half an hour of use, but it's not fully set for several weeks. I used black M4 countersunk hex bolts to keep the colour consistency. These screw into other M4 bolts in the box, along with some connecting nuts. I brought some computer PC fan dust covers and cut them up and stuck them over the hex-shaped air vents in the side of the case. The whole front panel is then attached to the computer case using several nuts and bolts in original mounting holes. A USB human interface device relay is used to control the front panel from inside Windows. This is an interesting solution that doesn't actually require any drivers, and they can be found readily on eBay. This relay is then connected to a spare USB header on the motherboard. The front panel is then connected to the PSU using an old school Molex connector. And that was how I did it. The setup has been running for a good while so far, and there have been no failures. I'm quite pleased with the result. I hope you've enjoyed this YouTube video.